In this video, we're going to find a power series representation for a function, and we'll be using integration as one of our steps. So we have the function f of x equals x squared times inverse tangent of x cubed, and we're being asked to determine the radius of convergence for this one as well. All right, so we're going to start with our geometric series. That's one we know. So our power series representation for 1 over 1 minus x is the sum n equals 0 to infinity of x to the n. All right, well, I can get a power series representation for 1 over 1 plus x squared by thinking of this as 1 minus negative x squared and replace the x in our previous power series with negative x squared. Why did I go to 1 over 1 plus x squared? Well, I recognize 1 over 1 plus x squared as the derivative of inverse tangent of x. So if I integrate 1 over 1 plus x squared, we'll get inverse tangent of x. All right, so this is negative 1 to the n, x to the 2n. So I need to integrate that series to get inverse tangent. We're doing an indefinite integral to start, so I have some arbitrary constant, and then we'll add 1 to the exponent and divide by the new exponent, or add 1 to the exponent and divide by that new exponent. We need to figure out what c is. Certainly on the right-hand side, when you put in 0 for x, you get 0. Put in 0 for inverse tangent, I also get 0, so we get c equals 0 in this case. So now we're ready to finish this off. We now have a power series representation for inverse tangent. Plug in x cubed for x. So we'll get an x cubed raised to the 2n plus 1. That's where this x to the 6n plus 3 comes from, just multiplying the exponents. Now multiply by x squared, bring it inside. We have 6n plus 3 plus 2, add our exponents, so we'll get x to the 6n plus 5 as our x term. And then our coefficients haven't changed at all because we're not plugging in anything for those. All right, so going back to the beginning of all of this, the geometric series, this 1 over 1 minus x representation, converges as long as the absolute value of x is less than 1. So the series for 1 over 1 plus x squared will converge as long as negative x squared is less than 1, and that gives us the exact same condition. Absolute value of x is less than 1. When we integrate our interval of, when we integrate, the radius of convergence stays the same. Might get endpoint convergence extra, but the radius stays the same, so it's also 1. And here we're just plugging in x cubed. Well, if absolute value of x is less than 1, absolute value of x cubed will be less than 1. It still is the same thing. It still says that absolute value of x has to be less than 1. Multiplying by x squared doesn't change anything, so all of these didn't change the radius of convergence at all, so our radius of convergence stays at 1.